Nanofibers Gateway, the first portal in the world that specializes in nanofibers. The portal is being built up by the Nafigate Corporation Global Center for Excellence. The portal's main aim is to create a global nanofiber community. The website is intended for entrepreneurs, investors, academicians, as well as the general public, and is in English, Chinese, Japanese, and Czech. In one place, you'll find all the information about the amazing world of nanofibers and their applications located in key areas: liquid filtration, energy, environment, health and personal care, food and packaging, and advanced materials. Welcome to the world of nanofibers. Nanofibers are so tiny that you never see one with the naked eye. What you see is only a reflection of light. Their true image can only be seen using an electron microscope. Nanofibers are part of the nano world, where sizes measure around 1/1,000,000th of a meter. Nanofibers are already changing our lives, giving new properties in things around us. A small drop of polymer solution is the starting point in making nanofiber. The drop is electrically charged in a high-voltage electric field to give birth to nanofiber. The fibers are laid over each other, resulting in a nanofiber mat. You can get an idea of the small size of nanofiber by comparison with bacteria, which are unable to penetrate through a nanofiber mat, as the pore size of the mat is much smaller than the size of the bacteria. Nanofibers are thus capable of protecting against bacteria and viruses. A nanofiber membrane can stop water from passing through, such as through clothes. Drops of water slip away on the mat's surface. However, textile materials of nanofibers are very breathable because air molecules can get through the same membrane easily. For example, a nanofiber breathing mask prevents bacteria from being inhaled, yet at the same time allows comfortable breathing. There are hundreds of nanofiber applications. Owing to their specific characteristics, nanofibers are a revolutionary material for the third millennium. Tissue is a fundamental building component of all animals' bodies. It is a group of similar cells that have a defined function. These cells can be of the same type but different in shape and function. Each tissue consists of two components, the cellular and extracellular matrix. To be less scientific, look at your hand, for example. It consists of many types of tissue that are made of a gigantic number of various types of cells. On the surface, you can see epidermis, which is the best known type of covering epithelial tissue. When you clench your fist, muscles, tendons, and ligaments stretch. These elements represent muscle and connective tissue, just like bones do. Also, our heart is just muscle tissue. When we cut ourselves, we perceive pain through nerve tissue, and blood is a type of liquid tissue. In general, we can say that everything you see on your body is made up of some type of tissue. There are many cases when tissue can be damaged, either because of injury or severe diseases such as cancer. Although our body is able to regenerate tissue to a certain degree, it is often helpless. How can we help? Tissue engineers combine various cells and materials to realistically imitate original and what is now damaged tissue. It is not easy at all for the tissue to start functioning normally again. The body is very smart and recognizes that something is different. If transplanted tissue is strange to the body attacks the tissue as if it was a disease. For some years, scientists have been able to grow stem cells that vary based on specific needs. They have found that nanofibers are very similar to the extracellular matrix that makes up the majority of their volume. The matrices serve as mechanical support for the tissue. It enables cells to be attached and also communication between the cells. It regulates division, migration, and the shape of cells. Cells grown on nanofibers are thus a bit cheated. However, they act naturally, and therefore we're able to create new tissue successfully. Best of all is that we can use patients' cells, cultivate the tissue, and place them in a desired place. Why do living organism cells prosper on non-woven textiles from nanofibers? The answer is in their delicate, tiny structure onto which the cells can catch easily. You can picture the cell as a group of climbers who secure, support each other, and climb on a rope that represents nanofibers. The mountaineers climb, support each other, and each of them has their own function, speed, and strength. If the rope and external conditions are good, all of the climbers can hold and reach the top safely. The aim is a well-attached cell because only such a cell can reproduce. The more cells, the faster new tissue is created. The nanofiber structure that is suitable for cell cultivation is called scaffold. The scaffold can be permanent or just short-term. After it fulfills its function, it deteriorates or can serve as food for the cells. Nanobio 3D matrix developed by Nafigate is an example of such scaffold. Lack of drinking water is an issue that touches lives of hundreds of millions of people on our planet. Nanofiber membranes offer a solution that is less energy-consuming and thus reduces the operating cost for the production of potable water. Nanofibers, mainly thanks to their high surface area, have brought new possibilities to filtration of liquids. A team of experts with a unique global experience and with the use of nanospider technology has developed membranes that have the following key benefits: exhibiting lower operational costs due to lower energy consumption, having higher efficiency and lower investment costs compared to conventional membranes. Properties may be customized to particular end use.
To demonstrate how nanofibers are efficient in liquid filtration, we have prepared a little experiment. In this experiment, we have two membranes. One is nanofiber membrane, having a pore diameter around 360 nanometers, and the standard membrane having much higher pore diameter, about 450.
Smaller pore size is usually related to lower flux rate, but nanofibers exhibit very high numbers of pores and so higher flux. In this case, 4 times higher compared to the standard.
Model solution was containing particles between 500 and 1000 nanometers. The filtration was conducted at pressure difference around 0.2 bars.
It took about a minute to prepare 3/4 of a liter of decontaminated drinking water, starting from model solution representing conventionally impure surface water. Cheers!